All right, the video today is going to be pretty short. This is at the bottom of your notes from the last page that we ended with. It had Avogadro's law at the top, combined gas law, and then at the very, very bottom, there's the ideal gas law. So the ideal gas law is slightly different than the other laws because the other laws have a gas and then something happens to it, and then you're looking for the new pressure or the new volume or the new temperature after a change has occurred. This gas law, you're looking at the variables that describe the gas at one instant. So maybe you want to know its pressure at a certain temperature and volume, or how many moles do you have at these different variables. And so you're not changing the gas. There's no ones and twos. This is the whole thing, and it describes a gas at a moment. So P is going to stand for pressure. When we have this P, this has to be in ATM. V is your volume. We need to make sure it's in liters for this formula. N is moles, so just a lot of times they'll give you grams. Just make sure you convert to moles. Temperature is your T. It's got to be in Kelvin. And then we haven't seen this R before. It's going to be a constant. It's 0.0821. Moles in Kelvin are at the bottom. ATM and liters are at the top. And like that whole thing right there is the unit for R. And if you have any ideal gas and you take its pressure and its volume and you divide by its moles and its temperature, you're always going to get this number. So that's where that's coming from. There may be other R's that you see. Like, I'm not sure if you're given an active problem and they provide you with a different R, what you're going to have to do is you're going to have to look behind it and say, okay, well, what units does it have? So if it's not ATM behind it, maybe it's torr. Make sure your pressure's in torr. If it's not liters, it's milliliters, make sure your volume's in milliliters. But lots of times this is the R that you're given or the R that you're expected to use, or if an R is not given, this is the one you can default to. So let me show you how this equation works. If you go to the next page in your notes, you'll see this example at the top. We're going to do one of these and then maybe another one on the mixed practice, and then you can practice on your own. I'll have the answer key to the rest of these mixed practice problems on Google Classroom for you to check. So if we read through this, we have a 23.8 liter balloon. It's filled with 88 grams. So that's our mass of carbon dioxide. And it's at a temperature of 15 degrees Celsius. What is the pressure? And notice it says in torr. We'll worry about that at the end. So if you think about Boyles, Strahls, Gay-Lussac's, Avogadro's, we can't use any of these. There's no two volumes, there's no two temperatures, there's no two pressures. So this scenario is just describing a gas at one instant at time. So we should be thinking, okay, let's use the ideal gas law. PV equals nRT. And then, since they don't provide us with an R, then we're going to use the R that I just gave you. And therefore, the units I just told you are the ones we have to use. So, we're going to solve for pressure. We don't know what it is, but when we do, that answer is going to be an ATM because of the R that we're using. For volume, we want liters. We already have liters, so we're good there. All right. Then we get over here to N. N is moles. We don't have moles. We have mass. So you can do one of two things. You can set up a dimensional analysis problem where you start off with your 88 grams of carbon dioxide, and therefore we need grams of carbon dioxide on the bottom of the next step, 1 mole on the top. And y'all, anytime you need to get into or out of grams, you go to the periodic table. If you add up 1 carbon and you add up, which is 12 grams, and you add up 2 oxygens, 16 plus 16, and you put that all together, you're going to get about 44 grams. And so when we divide that out, we're around 2 moles. If you didn't like dimensional analysis, another thing you could do is kind of pretend you're in a stoich chart of carbon dioxide. And so remember, it goes mass, moles, coefficient equivalent, but we're not doing stoich here. So your mass would be 88. You would go to the periodic table, you would add up your molar mass, and remember when you go down, you divide. And so either way, we're gonna get 2 moles. So that's what we're gonna plug in for N over here. R is gonna, and temperature needs to be in Kelvin, so don't plug in 15, you need to get it to Kelvin, so always add that 273 to it. We're getting 1.99 ATM, but that's not our answer, because let's just go back and remember it said, what is your pressure in torr? So pay attention in case you see this in active too. You don't want to get excited, you got an answer and then stop too early. So the way you're going to go from ATM to torrs, you're going to go back to this first page. Over here, 1 ATM is 760 torr. So 1 ATM, 760 torr, 510 torr. All right, so on the next page, it's all the problems that I've given you formulas for mixed. So some of these might be Boyle's, Charles, Avogadro's, combined gas law, Gay-Lussac's, or the ideal. So what you're gonna have to do is you're gonna have to read through these and decide, okay, what do I have? So I really feel like labeling your numbers and then kind of looking and seeing, okay, I can take these and this fits this formula or that formula. Works well. I won't do all of number 1, but I'll just give you an idea of how to kind of tackle it. And then I want you to stop and try all of these and then go to Google Classroom, and I'll have the answer key there, and then that way you can check them, because your homework tomorrow that opens will be on combined gas laws and ideal gas laws, and it won't tell you which is which. First, get the bends if they come up too fast, because gas in their blood vessels expand, forming bubbles in their blood. If a diver has 0.05 liters of gas in his blood, so that looks like a volume, under a pressure of 250 ATM, and then rises instantaneously to a depth where his blood has a pressure of 50 ATM, so another pressure, volume B. So immediately, I'm not thinking it's the law that I just showed you, the ideal gas law, because I have 2 volumes, 2 pressures. And so what I would do is I would think of the combined gas law, because there's no moles in this thing. And I would say, okay, well, I know pressure, volume were talked about, and I would take these out. And this looks like it's a problem for Boyle's law. So I'm going to be using this formula to solve it. And then I would go in and plug. Just one more. If I look at number 2, a gas has a temperature of 14 degrees Celsius, and this is the volume, 4.5 liters. If the temperature is raised, so there's another temperature, to 29 degrees Celsius, and the pressure is not changed, what is the new volume? So when it says it's not changed, they're kind of letting you know you can let go of pressure in this problem. Originally, though, I'm going to write it out. And so now I can see I have a Charles's Law problem. And if you get to a question where you don't have 2 of everything, or maybe there's moles in it, it's going to be one of these, right? Try them all out, see if you can solve them, and then go to Google Classroom and check your work.